In today's video, we are going to talk about the transcendental function, which is the second major type of function. We have talked about algebraic function in the previous video. In this video, we are going to talk in depth about function. So what is transcendental function? So let me write it over here. Transcendental function. So transcendental functions are those functions which are not algebraic. Not algebraic. We have talked about algebraic function in detail in the previous video. So there are three major types of algebraic function. The first one is polynomial. The second one is rational. The third one is irrational. So the function which is not polynomial, the function which is not rational or irrational, that function is called transcendental function. So there are some types of transcendental functions. So we are going to discuss some of them, and in the next video we are going to discuss more of them. So the first type of transcendental function is trigonometric function. Trigonometric function. So this is the first type of algebraic function. Not algebraic function. This is the first type of transcendental function, trigonometric function. We all know about trigonometry. Trigonometry is a study of sides and angles of triangle. Okay, we all know about trigonometry. Trigonometry is the study of angles and sides. This is basically the study of angles and sides of what? Of triangle. So in this we study about triangles and sides and angles and things like that. So this is about trigonometry. So we all know that there are 6 trigonometric functions. We are going to discuss the domain of those trigonometric functions and the range of those trigonometric functions. So the first one is sine. Sine x. Sine is a trigonometric function. The domain, let me make a table over here. So this is the table. Okay, this is the table. This is function. Okay, this is function. This is domain, and this is range. We all know about domain and range. Domain is the independent variable in the function, and range is the dependent variable in the function. Domain is the input, range is the output. We have talked about this in detail in our functions video. So the first function, the first trigonometric function is sine x. Sine is a trigonometric function. So the domain of sine function is, I would say, all real number. You can put all real number in the domain of sine function. In the range is -1, from -1 to 1. Okay, so the range is in the closed interval of -1 and 1. So this was about sine function. The second trigonometric function is cos x. Cos is the second trigonometric function, and the domain of cos is also all real number. Okay, the domain of cos is all real number. And the range, okay, I will write over here, the range is also between -1 and 1, including -1 and 1. The interval is closed interval. So the range is between -1 and 1, including -1 and 1, and the domains are all real number. So this was about cos function. So the third is sine cos. So third one would be tangent tan x. So the domain of tan is, for all x belong to real number, you know, but there are some limitation. Okay, x does not equal to, it would not be equal, to what? 2n plus 1 pi by 2. Okay, we can't put x equals 2n plus 1 pi by 2. Why? We all know that tangent is basically sine by cos. Okay, so we don't want 0 in the denominator. Okay, and cos is 0 at 2n plus 1 pi by 2. Okay, cos is 0. So if I put, this and at the place of x, then cos would be 0. So the the function the function the function would be undefined. So it means that the tan function is defined for all real number, okay, except 2n plus 1 into pi by 2. Okay, we can't put this we can put this domain here in the tan function. Okay, we can put this value in the tan function because the tan function would be undefined, and we don't want a function to be undefined. So what is the range? So the range is all real number. We can put on, the range, the answer, the output would also be, we will always belong to real numbers. Okay, the range will always be real numbers. So the fourth the fourth trigonometric function is secant. The fourth trigonometric function is secant x, and we all know that secant is equal 1 over cos x. Same condition as we've talked here, that we don't want a cos to be 0, because then it would be a disaster. Okay, same case over here, we don't want the denominator to be 0. So same domain for tan, same domain for secant. Okay, so domain would be for all x belong to a real number such that x does not equal to 2n plus 1 pi by 2. Okay, and the range, okay, so the range is y is greater or equal to 1, or y is less than or equal to -1. So this is the range. Okay, the range of secant is greater than or equal to 1, or less than or equal to -1. Okay, and the fifth trigonometric function is cosecant. Cosecant x, and we all know that cosecant is 1 over sine. Okay, 1 over sine x. So as you can see here, now in the denominator there is sine, and sine is undefined for n pi. Okay, n pi mean 0 degree, 180 degree, 360 degree, and so on. So for all x, right over here, so let me write it in another color. So cosecant x is defined. Why is the color not changing? Okay, so sorry. So the cosecant x is defined for all x belong to a real number. It means that we can put all real number, but still there are some limitation. There are some values that we can't put in cosecant function. If we put, then the function is going to be undefined. So for all x belong to real number such that x does not equal to n pi, and I already told you that n pi is 0 degree and 180 degree, 360 degree. Put n 1, 2, 3, 4, and you will get the angles. Okay, so this is in radian. These are the angles, but in radian. Okay, These are the angles, but in radian. So what is the range of cosecant function? So the range of cosecant and secant are the same. Okay, the range of cosecant function and a range of the secant function, they both are the same, which is y is greater than or equal to 1, or y is less than or equal to -1. So this is also the range of cosecant function. So here, the last, okay, this last trigonometric function, the last trigonometric function is cotangent x, which is the last trigonometric function. And we know that cotangent is cos x by sine x. So as you can see that here, the in the denominator there is sine x. So we don't want the sine, we don't want the denominator to be 0. Okay, because if the denominator is 0, then the function is going to be undefined, and we don't want that. Okay, so the range of the domain of cosecant and the domain of cotangent, they both are same. So I would say that the domain of the cotangent is, for all x belong to real number, such that x does not equal n pi. It means that we can put x 0, we can put x 180, 360, and so on. We can put that because there would be a disaster. The function would be undefined, and we don't want it. And the range, okay, the output, the dependent variable, is going to be all real number. Okay, it is going to give us all